Hey everyone, it's time to talk about support mechanisms again. We've talked about supports in 2 dimensions in a previous video, but in this video we want to look at the support mechanisms in 3 dimensions. And so moments are going to become much more important in this than they were in the 2D videos. But let's take a look. Okay, so the first one we'll talk about is a ball bearing or some kind of a roller. This will be a roller in 3D. Remember we had rollers in 2D, and they only applied normal forces. So the same thing holds true here, except I'm going to assume frictionless contact. So this ball bearing is on a frictionless surface, or this roller is on a frictionless surface. So I might simulate that with a little wheel like this on the top of this binder, right? And so clearly I'm free to move because of the roller left and right? I can move left and right with no problem. So no forces are exerted in the x direction. If it's frictionless, I can move back and forth. So that's the z direction in our context, right? But I can't move down. I can move up, so I can't exert a force in the downward direction, but I can exert a force. The surface here is exerting a force in the upward direction. And so that's a normal force. So I labeled it F sub n. I could have labeled it F sub y as well, doesn't matter. But I wanted to just emphasize the fact this is a normal force that's being exerted. All right, so because it's a frictionless surface, I can twist around in circles. So this mechanism doesn't apply any moments around the y-axis. I can rotate like this, no problem. So there are no moments around the z-axis. And then I can rotate this way as well. Excuse me, no moments around the x-axis this way, and no moments around the z-axis. Okay, so I'm not stopping any rotation. Since I'm not stopping any rotation, then I consider this to be applying or unable to apply moments. So all a roller can do is normal forces in the y direction or perpendicular to the surface. Okay, they can only exert forces perpendicular to the surface. All right, now if there was some sort of a mechanism up here to keep it from moving up, then it could exert forces up and down. But if it's on a book like this is, I can't exert forces down. I'm free to pull it up, but I can't push it into the book. All right, in a similar situation, we've got a roller on a rough surface or on a rail. So assume, for example, the rail might be the edge of this binder. Okay, and so it rolls on the edge of the binder, still exerting a force in the normal direction, in the y direction, but I'm now no longer, well, if I push hard enough, I guess, I'm no longer able to move towards the camera or away from the camera. So there's a z force being exerted by the rail. This could be a really rough frictional surface, and so that's not able to move along that surface. This is not really very rough, so I easily could push it if I wanted to, but it does exert a little bit of a force in the z direction, right? And so I've got a z force. I labeled it as friction. I guess if it's on a rail, it's really not friction. It's actually a normal force there, but it's in the z direction, okay? So let's consider that just to be some sort of a force in the z direction. All right, so normal force, z force. Again, I'm not exerting any moments. Spinning that system will be allowed in all 3 directions, and so no moments are applied in that situation. All right, now let's take a look at a different support mechanism. Let's talk about a ball and socket. All right, so in the case of a ball and socket, the object is not allowed to move in the x, y, or z direction. So a really good ball and socket is your shoulder. Okay, I can't pull my arm away from my shoulder, I hope. I can't pull it up and I can't pull it towards the camera. If I exert forces in those directions, if I pull in this direction, the arm doesn't move towards the camera. If I push in this direction, the arm doesn't move up, the arm doesn't move down. If I pull it out this way, the arm does not move in that direction. But I can rotate around that axis, I can rotate around this axis, and I can rotate around, so this would be rotations around the y-axis, because that's up. Right? This is rotations around the z-axis, and then this is rotations around the x-axis. And so those rotations are allowed. So there are no moments that are going to be exerted by a ball and socket. No moments will be exerted by a ball and socket. But forces are exerted or can be exerted in all three directions. And so if I see this on a force diagram, I'm going to put in an X, Y, and a Z force potentially there. What those values are, I don't know, but I can put them in there potentially. And then a similar support is a fixed support. Okay, so I've got a fixed support here on this ring stand. Okay, this is screwed into the base. So if I lift up, it doesn't go up or down, doesn't go towards the camera or away from the camera, right? And it doesn't go to the right or to the left because it's fixed into this base. And so that's not going to be allowed to happen. In addition, if the base is fixed, I can't rotate it around the x-axis, I can't rotate it around the y-axis, and I can't rotate it around the z-axis. Of course, I'm rotating it here because my hand is too weak. But this would be like a telephone pole in the ground. Try to twist a telephone pole or push it over, and it's not likely to happen unless you're like the man of steel. So that's not going to happen. And then you cannot lift it out of the ground easily. You can't push it to the left or to the right. You can't push it forward and backward because it's fixed in the ground. So a fixed support will apply forces in all three directions, X, Y, and Z, and it will also apply moments retarding rotation in the X, Y, or around the X, Y, or Z axis. Okay, so fixed supports do all of those things. All right, so there's a couple of support mechanisms. We'll look at a couple more in the next video. If you have any questions, please leave them in the comments below. Thank you.